Hey, boys and girls, welcome back to another edition of Classifying Triangles. Yes, we're still on Classifying Triangles, but this time we're going to do it on a coordinate plane. So it gives us points, and we have to classify each triangle by its side. So is it scalene? Is it equilateral? Or is it isosceles? I don't know. So we got to see. So we got 13 and 14. Copy those down in your notes. Let's figure out what triangle RST actually is, shall we? Boop. Here you go. Classifying triangles on a coordinate plane. So first thing you got to do is draw your coordinate plane, right? So R is 0, 2. S is 2, 5, 1, 2, 1, 2, 3, 4, 5. And T is 4, 2. 1, 2, 3, 4, 1, 2. Okay, so there you go. So we have to figure out the length of all the sides. Well, one thing we can do is this going straight across, R to T is really simple because that's just 1, 2, 3, 4. So RT is 4 spaces. I'm going to put that off to the side, or I can put it right here if I want. Do that with me. Okay, so now you can't count diagonally, but there are 2 ways to do it. Do you remember? Yeah, distance formula or Pythagorean theorem. So it doesn't matter. So let's just review both real quick. So you go. So this is 1, 2, 3, and this is 1, 2. So you're gonna have the hypotenuse. So this is what we're trying to figure out. So that's gonna be C. Let's say. So you can say 3 squared plus 2 squared equals C squared. Leg squared plus leg squared equals hypotenuse squared. So that's going to be 9 plus 4 equals C squared. Square root both sides. Oh, this is 11, sorry. Square root both sides. Sorry, 13. I don't know what I'm doing. 13. So the square root of 13, we don't know what that is. That's a irrational number. So C equals the square root of 13. So I'm just going to leave it there as square root of 13 right now. So that's what SRRS is. Square root of 13. How else could you have done it? You could also have done the distance formula. So I should get square root of 13 same way. So that's the change in the x's. So 0 and 2. How far are they apart? 0 and 2, those are 2 apart. And then the y's, 2 and 5. How far are they apart? That's 3. Oh, it's the same thing, isn't it? Because that's the square root of 4 plus 9. Oh my goodness, the same answer. So no matter what you do, distance formula or Pythagorean theorem, you should get the same answer, and we do. Okay, so that leaves S to T. We need all 3 sides. We need to only have 2. So let's do it. So this is, let's use the distance formula because I think that's a little easier, a little quicker. Well, you can do this if you want. Oh, 2 and 3, right? That's the same as this part. So let's do distance formula. 2 times 2 and 4, those are 2 apart. So that's this 2, those the x part. And then the y's 5 and 2, so that's 3 apart right here. So 5 and 2 go from 2 to 5, that's 3. So you're essentially just doing the same thing. So that's 4 plus 9, which is square root of 13 right here. So square root of 13. So we have 2 sides that are congruent and 1 side that is not congruent to the other 2. So this is what? Yeah, isosceles. This is an isosceles triangle. That's how we get it. Let's do one more before you try. Here you go. RST. 1, 3 is R, S is 4, 7, and T is 5, 4. Picture time. R is 1, 3, 1, 1, 2, 3. Really important that you have graph paper, but if you don't, that's okay. You can just use distance formula. S is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. S is 4, 7. And T is 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Got it. There you go. Okay, so we don't have this luxury of just counting across. We actually have to do distance formula of all three sides in this case. No problem. Pick a side, it doesn't matter. Let's do RS first. So that's the square root of change in the x's. Or I can use Pythagorean theorem here. Change in the x's would be between 1 and 4. That's going to be 3. And change in the y, that's 3, right? Change in the y's, 3 to 7, that's going to be 4. Which is the same thing as this, 3 and 4. We're finding this hypotenuse. So that's 9 plus 16. 4 times 4 is 16. Square root of 25, which is, boop, 5 spaces. So this is 5 right here. So RS equals 5. Okay, next, let's do S to T. That's square root of, if I want to do that, I can do Pythagorean theorem. There's my right angle, right triangle. So changing the x's 4 to 5, that's 1. Changing the y's 7 to 4, that's 1, 2, 3. So that's 1 times 1 is 1. 3 times 3 is 9. So that's square root of 10. Okay, so it's not equilateral. I know that right now. So ST is square root of 10. If you want to know what square root of 10 is, that's an irrational number. You just type it in a calculator like this, square root of 10, and you get 3.16222, something like that, which is not 5. So it's not equal. So this is square root of 10. Label your picture. Always label your picture. We got one more to do, R to T. So square root of, so the x's are 1, 2, 3, 4 apart. 1 to 5 is 4 apart. And then the y's, 3 to 4, that's going to be 1 apart, like that. So square root of 4 squared, 4 times 4 is 16. 1 times 1 is 1. 16 plus 1 is square root of 17. Okay, so that means RT is square root of 17. It looks like we have 3 different measures of all the sides. So what do we call that? Yeah! Scalene triangle. So number 14, RST in that case. Triangle RST is a scalene triangle because all 3 sides are not congruent. Cool. All right, now your turn. Try 10 on this page here. So 10, 11. 10, 11. So we got KPL. Go ahead and put it in your notes like this and try it. Go. What kind of triangle is that? All right, see if you got it. K is 1, 2, 3, negative 3, 2, right here. K is negative 3, 2. Always put the letter in the point right there. So P is 2, 1 right here. And L is negative 2, negative 3 right here. Okay, so there's my triangle right there. So I need to do distance formula with all 3 sides. So KP, square root of, I can do this to check, create my right triangle. So negative 3 to 2, how many spaces is that? If I need to count 1, 2, 3, 4, 5, I can do that like on a number line. So that's 5. And then on the y's, 2 to 1. So that's, you just drop down 1, right? So that's 1. So square root of 5 squared is 25. 1 times 1 is 1. So it's square root of 26 is KP. So this is the square root of 26. Okay, now P to L, or LP, is the square root of. Let's see. So that would be negative 2 to 2. That's the x's, right? So it's 1, 2, 3, 4 across. And the y's, negative 3 to 1, is how many spaces? 1, 2, 3, 4. So it's 4 squared and 4 squared. So it's 16 plus 16. So that's going to be square root of 32, which I don't know the square root of. Square root of 32, do I know that one? Nope, there you go. So it's 5 point something. So that's a different measure. Got it. Okay, this one, K to L. Square root of. Okay, the x's are 1 apart, -3 to -2, and the y's 2 to -3. 2 to -3 is 5 apart. So that's going to be 1 squared is 1. 5 squared is 25. So that's square root of 26. Woo! Looks like I have square root of 26 here, square root of 26 here, and I have square root of 32. So I have two sides that are congruent. So what do we call that? Yeah, isosceles. Yeah, there we go. Isosceles triangle for number 10. Got it. Okay, last but not least, let's do number 11. Go. Okay, let's see what we got. I'm going to go fast through this one. So K is 1, 2, 3, 4, 5. 1, 2, 3. K is 5, -3. And P is 1, 2, 3. 1, 2, 3, 4. And L is -1, 1. So hopefully you got this one. Let's see if you did. So PK, or KP, is 3 to 5, which is 2. And 4 to -3. 4 to -3, which is 7. So 2 squared is 4 plus 49, which is square root of 53 is this side. Got it. So this side right here, this is LP. Square root of the x's, -1 to 3, which is 4. And the y's, you can just count, is 4 to 1, which is 3. So that's going to be 16 plus 9, which is square root of 25, which is 5. Because 5 times 5 is 25. So this is 5 here. Last but not least, LK, or KL. So -1 to 5 is 6 on the x, and 1 to -3 is 4 on the x. So that's square root of 36 plus 16, which is 52. Square root of 52. So it looks like I have 5, square root of 53, and square root of 52. So that means that all three are not congruent. So this is a scalene triangle. There you go. Hopefully you got that. Good work, everybody. Keep crushing.